Hello, Happy New Year, and welcome CTS266 Section 840 students for the Spring 2016 semester at Anne Arundel Community College. The following activity is going to be Discovery Activity 1 from our Cisco Learning Labs curriculum. Again, another fantastic Cisco Learning Labs activity to sort of break the ice here and introduce us to Layer 2. So without any further ado, let's go ahead and jump into Discovery Activity 1 here, where we're going to be investigating the Kam table. Now I'm going to put a couple terms up over here on the right-hand side. The Kam table stands for Content Addressable Memory. Now, there's no pun here that this is backwards, but you'll also commonly, I should say more commonly here to it referred to as the MAC address table, or the Media Access Control, the MAC address table, which is the Layer 2 address that we are interested in right now. For those of you that took the route course in the fall, we were dealing with Layer 3 addressing, right, and prefixes and routes. With the switch course, it's all about Layer 2 of the OSI model. And the PDU at Layer 2 is, we'll put the PDU here, the PDU at Layer 2 is the MAC address. And so that's really the address that we're going to be interested in. And let's go ahead and jump in here. So step one, it wants us basically from PC1, it would like us to generate some information, some traffic to all devices in the subnet. Now, a quick note, remember, when you're in the Learning Labs interface here, you're not actually on a real physical Cisco switch. You're on what's called IOU, or iOS on Unix. So this is sort of a simulator of the Cisco iOS. However, it's going to allow us to do everything we need to do, but I may from time to time jump to actual physical Cisco switches to show you what you would actually see when there's some significant differences. So let's go ahead and jump in here. It wants us to run an extended ping. So we're going to go from user exec to privilege exec, and we just use the en or enable command to get into privilege exec mode. Now let's go ahead and type in the ping command. Now, if I were to type in ping and then put in an IP address, I could certainly do that. If we want to get into the extended ping, notice that right here you see when we type in ping, I can also enter a carriage return, which is simply hitting the enter or the return key. Now this puts me into an extended ping, right? So the protocol, we're going to leave it at IP. My target address is going to be 10.1.1.255. Now, we're pinging the broadcast address of the subnet with which we're working. So if I were to take a look, and we will here shortly, we'll see that the actual subnet is going to be 10.1.1.0/24. Now remember, the first usable IP is going to be .1. The last usable IP in a /24 is going to be .254, and then my broadcast address would be that 255, right? So this is the subnet we're dealing with. When I go into the extended ping, I'm simply going to try to ping the broadcast address, which should generate pings to all of, again, I'm broadcasting this ping out, so everybody on the segment is going to receive this ping, and I'll send out, we'll do 20, datagram size, we'll make it 1500, and then we'll just work our way through here, and you can see I'm going to be sending 20 1500 byte ICMP echoes out to the broadcast address. And so since it's going out to the broadcast address, anybody on this network segment, the 10.1.1.0/24, anybody who's listening out there is going to be responding. And here you go. You can see that we've got some common respondents, or I should say responders, each time that ping packet gets sent out. And we chose 20, and that is why you're seeing that this number here is going to continue to increment until we get up to 20, right? So you can see we hit at 19. Whoops. Take that guy out. We hit up to 19, right? So that is our 20 attempts. So who were the responders? Well, it was 10, 1, 1, 2, 4, 5, and 3. So 2, 3, 4, and 5. right? So those are the IPs that we have responding: 10.1.1.2, 3, 4, and 5. So let's go ahead and actually what I should have done there, let me do it again here: 10.1.1.2, 3, 4, and 5. So these were the nodes that were responding to my ping request from PC1. So what we're going to do now is let's get onto the switch, right? If we take a look at the topology here, so again, we generated the pings from PC1, and we basically just sent them out to the broadcast address. And we were receiving responses from .2, .3, .4, and .5. So actually, let me pull those back. So we received a response from 2, 3, 4, and 5. So now we're going to jump onto the switch, and let's see what the MAC address table looks like on the switch. So we jump onto the switch here. We'll go from user exec into privilege exec. Let me click in here. Go from user exec to privilege exec. Now, how do we see the MAC address table? Well, it's simply show MAC address table. As you can see here, I want to print out some of the other options that we've got that we're going to be taking a look at. So I'm just simply going to say show MAC address table, and I'm going to hit enter. Now, here's a list of all of the MAC addresses that the switch has learned about. And how does the switch learn about MAC addresses? And this is definitely something that you want to remember, is it learns based off the source MAC address. So the switch receives a layer 2 frame, and that frame is going to have a source MAC address, right? The node MAC address from which the request or from which the frame is originating, and then it's going to have a destination MAC address. But the switch learns, and when I say learn, what I mean is it's actually entering or making a table of the MAC addresses based off of the layer 2 frames it's receiving using the source MAC address. So what do we see here? We're learning about 600, and I'm going to go ahead and, this is the whole MAC address, but I'll refer to them here as 600, 700, 800, 900, and then A00. Now what's interesting is here are the ports on which it learned about the indicated MAC address. So the switch learned about MAC address 600 on port Ethernet 01. So it received, and let's translate what this says, is that the switch received a layer 2 frame in which the source MAC address was AABBCC000600 on port Ethernet 01. So if I transition back, and let's leave that there for now, if I transition back on Ethernet 01, so here's Ethernet 01 on the switch, right? So it's on this port right here that the switch learned about that MAC address. Now remember, switches learn based off the source MAC address. So we're going to go back to the PC here, PC1, and we're going to take a look and see what is the MAC address, what's the burned in address on Ethernet 00. So let me actually pull back those there, and let's go on to PC1 where we did our pings before, and I'm going to go ahead and, whoops, did not want to do that, and I apologize there. Let's just dump this window here. There we go. So let's go back to PC1 here, and we're going to clear our entire screen. And on PC1, if I say show interface Ethernet 0, and I've already forgotten here, 00. Show interface Ethernet 00, what do we see as the burned in MAC address? And here it is. You can see. Now again, it's not going to look like this on it. It's not going to say AMD-P2 on your Cisco switch, but this is my burned in MAC address. So when PC1 is originating traffic, there's going to be a layer 2, there are going to be many layer 2 frames that show up at the switch, and this will be the source MAC address. Now, the reason the switch is learning based on the source MAC address is because that MAC address table the switch is putting together and creating helps that switch, when traffic shows up, destined for PC1. And the switch looks at the layer 2 destination MAC address table, or the layer 2 table it has, the MAC address table, and it says if the destination MAC address is AABBCC000600, out which port am I sending that traffic? And so since the switch learned about this source MAC address, or this MAC address on port Ethernet 01, it is out that port on the switch that this traffic will be sent. So again, the switch learns about, and we'll come back to our diagram here, the switch learns about traffic on the ingress, right? It learns about traffic based off the source MAC address. It creates that table saying that if I get some traffic coming from maybe this direction or this direction, where it's going to the MAC, and again, these are just the last 4 hex characters in that MAC, 0600, which we know is here. When that switch receives that layer 2 frame, it says, hey, out which port am I sending that traffic? Well, it's going to go out Ethernet 01, because that's the port on which I learned about this MAC address. Okay, so enough about that. I think we've talked enough here to where now, if I were to say show MAC address table again, we've only got these 3 entries here. So we've had some entries, specifically those on Ethernet 1.1. We've had those time out, right? So those have disappeared. Now, one of the most common questions that learners have, especially learners new to layer 2, is we take a look here and you can see the type of MAC address. So what VLAN are we dealing with? Well, we haven't created any, so we have the Cisco default VLAN, which is simply VLAN 1. Then we've got our MAC addresses that are listed here. Now the type. You can see that we only have dynamically learned MACs. And what this means is, it means that the switch is learning about these in a dynamic fashion, meaning it's learning about these when it is learning the source MAC addresses as they show up on the different ports of the switch. And so those are dynamic entries. Now, on a real Cisco switch, and this again is a super common question that new learners have, and let's pop over here to Secure CRT, that new learners have is they go onto a switch and they say show MAC address table, and then they see this. And you can see that we have all of these static MAC addresses, right? Now, we have some dynamics, or we have a single dynamic. And again, this is a Cisco 3750 switch, but take a look at this. And it says it's good for all VLANs, and who is the port? Well, the port is the CPU, because these static entries, specifically these static entries that we're looking at right here, I'm not talking about you creating a static entry. I'm saying that the default static entries that we see, and again, this is a 3750, these are what are referred to as base MAC addresses, right? And what are these used for? Well, these are used by the switch for internal processing, right? So the switch is allocating these base MAC addresses on its own as static entries, which means they will always be in here. They are static. They are never going to time out. And that's what static means. Remember, dynamic means that it's learning about the address in the layer 2 frame based off the source MAC address. And then that dynamic entry can time out after a certain amount of time. And we're going to talk about that here shortly. Again, the opposite of that is a static entry, which will always be in the MAC address table and will not time out. And the key difference here between a static entry that you would create and a static entry that's in here by default, like these 20 plus entries seem to, or 20, it seems about 20, these are created by the switch and they're used by the switch. So remember, these are base MAC address entries, okay, or base MAC addresses that are static, excuse me, that are created by the switch for its own internal processing, which is why the port owner is the CPU. All right, so let's step back here. Give me a second. I'm going to roll around. All right, so let's come back to our switches here, and let's see. Do we see... And I'm hoping that we're going to have them time out. No, they're not timing out. Again, and this may be because it's IOU. But again, dynamic entries can time out. Now, step 3 in the discovery activity. If you're interested in only seeing addresses that are being learned on a certain port, you can simply say, show MAC address table, and then I can put down the interface. So I would say interface Ethernet 01. And then it'll only show me the MAC address that I've learned on that interface. So if I were to ask you, how could you see the MAC address for PC2 and PC3, which commands could you run? Exactly. You could simply come over to the switch and say, show MAC address Ethernet 02 and Ethernet 03. And this is showing me, again, only the MAC address that I've learned on that specific interface, and that is the MAC. And it's dynamic, which tells me that the switch learned about this address dynamically when it learned the source MAC address in the layer 2 frame that it received on that port. And same thing here. This is PC3, right? Ethernet 03. And that's the MAC address for PC3. All right, so let's clear the screen. Now, what you could also do, and the activity doesn't talk about this, but this, when you're on a real Cisco switch, is a lifesaver. So if I wanted to say show MAC address table, and let's say I only wanted to see the dynamic entries, because again, remember, why would I want to do that? Well, if I type show MAC address table and I hit enter, do I really want to have to work through or get past all of these static entries here, which I'm probably not too interested in, just to get down to the one entry I am interested in, which is that one entry down there, that one dynamic entry? Well, the answer is probably not. So what I can say is I can say show MAC address table dynamic. And that is going to show me only the dynamically learned entries. Now, if for some bizarre reason you only wanted to see the statically learned entries, you could change the keyword to static. And as you can see here, it omitted that single dynamically learned entry that we had. So again, show MAC address table dynamic, show MAC address table static, or if you're interested in only seeing, if you're only interested in seeing what is on a specific interface, 1045, you can then just put in the interface by itself, and that's going to show you the source MAC address that was learned on that switch port. All right, let's transition back to the activity where I could put dynamic in, but here, does that really buy us much of anything? It really doesn't, because if I were to say that or this, I'm going to see all the dynamic entries. Because again, this is IOU. It is not a real physical Cisco switch. Therefore, for whatever reason, there are no static entries here. So if I were to change this out and say show MAC address table static, we don't see anything, right? All right, so we've got our 5 entries. We've learned how the switch learns about the MAC addresses. It learns them based on the source MAC address. We also learned the difference between the static and the dynamic. So now we're going to learn some information using the show CDP neighbor command. Or first, there's a question here. It says, how is it possible for switch 1, and this, yes, and this is also a common question. So how is it possible for switch 1 to see 2 MAC addresses through port Ethernet 1.1? And if we go back to the diagram, what is it that we know about Ethernet 1.1 on the switch? Well, this is Ethernet 1.1. Here is our switch. And then the big question is, and you can see we've got the question mark, what is out here? Well, that's kind of what step 4 is leading up to. It's asking you, how is it possible? Because, again, these only have these ports, right, 1, 2, and 3, only have a single MAC address associated with them. How is it possible that Ethernet 1.1 has more than one? Well, it's actually pretty easy. And that is Ethernet 1.1 is connected to a switch, right? That this is a switch, and that this switch could have other hosts, we'll say PC4, and again, I don't know that there are other PCs out here, but this is a possibility. That we've got PC4, PC5, and PC6 over here, and actually the possibility would be that it's only 2 PCs, but again, you can have multiple PCs hanging off over here, and this port right here, this switch would be reporting that on Ethernet 1.1, it would be learning about all of the other PCs that are plugged in over here, their MAC addresses. And this is how that would happen, right? And typically this is going to be a trunk port. And we'll be talking about trunk ports later on. And the trunk port simply allows you to have multiple VLANs transit or travel across that link. All right, so let's go ahead and clear the screen here. And let's come back to our switch. And here's what it's talking about, right? We're learning about 2 entries here. Well, when I'm learning about multiple entries, there's a very good possibility that what is plugged into my switch's Ethernet 1.1, the switch that we can see, is that it's a trunk link coming from another switch. So let's take a look at how would we see that. Well, I could say show CDP neighbors. I'm going to do a question mark here. You can see there's all kinds of different options. And the ones that we're going to be interested in are going to be show CDP neighbors and show CDP neighbor detail. So show CDP neighbors, so here it is right here. It shows us that what do we actually have connected into Ethernet 1.1? Well, the device ID, it is switch 2. You can see we're switch 1, so what's plugged in on the other side? It's switch 2. Now, capabilities, and we'll get more into this as we move along, it looks as if this is a multi-layer switch, that it's able to do routing and switching. And here's a very important thing. Platform, Linux, Unix, and it left off the X, but it's Linux, Unix, right? So this is what we call IOU. And it's basically just a simulator that Cisco created. That way they don't have to have, millions and millions of physical switches so that we can do these labs. You can do it in software, right? And it's a simulator. And then what port? Out which port are we learning about these guys? Or their port ID is Ethernet 1.1. So we're learning about them out the local interface Ethernet 1.1. And the port ID is Ethernet 1.1. So again, this is how we can see some information about who is connected to us, which other Cisco components might be connected to us. So if I say show CDP neighbors detail, I would see some additional information here. You can see capabilities, that R and that S, router and switch, so it's a multi-layer capable device. And here's the version of software, right? So here you can see the i86 Linux. It's got the layer 2 image K9, right? So we can do security features. It's an experimental version. And then we've got some copyright information here. And this, it's kind of hidden there, that version 15.0. And we're using CDP advertisement version 2. Now, what does that look like on a real Cisco switch? So here on the switch, if I were to say show CDP neighbors, you can see we've got a little more information. I'm actually plugged into 2 switches off of this single switch. And you can see the local interfaces, right? So it looks very much the same. We see the device ID is simply the host name of the device. And this is only a layer 2 device. And you can see we have our capability codes here. So before we saw the R for router, now I'm simply seeing the S and the I. So what does that mean? Well, it means it's running IGMP, or it's got the capability of doing IGMP if we're doing multicasting. And then the S is simply for a switch. So it means it's a layer 2 capable device right now, the way it's configured, and IGMP. Now, these are things I can change, right? But by default, this 3750 is capable of IGMP and of being a layer 2 device. Now, here's the platform. Remember, I said these are 3750s. And then here is the fast Ethernet port on the remote switch. And the reason I know it's the remote switch, it was a little tougher to see that earlier, was that these were the same. The local interface and the port ID were the same. But here, right, you can see going over to switch 2, my local interface on switch 1 is 1045. The remote interface is 6045, right? So again, these are stackable, which is why we've got this 6045 for the port numbers, right? But again, this is the remote port ID. This is the local port ID. And so that's what it looks like on a real physical Cisco switch. So let's get back into the lab here. And you can see again, we've got the same capability codes that display here. All right, so on switch 1, if I were to say show run include routing, or show run, and let's see if it has, it should have that IP. If it doesn't have the IP routing command, that's okay. And it looks like it does not. All right, so I was looking to see if they had the IP routing on in order to get that R in the capability code. But it looks like it, just based off the fact that it's IOU, is going to go ahead and say that yes, this is a multi-layer switch. All right, so now we're going to talk about the Kam Aging Time. Remember when I said show MAC address table, or the MAC address table aging time, you'll notice that these entries are staying in the table. These dynamic entries here are staying in the table, but those two that we learned out Ethernet 1.1, those are not. So they are timing out. So how do I know how long I'm going to hold on to an entry? Well, I simply say show MAC address table aging time. And I'll do a question mark here. You can see I can look at specific VLANs, but we only have a single VLAN. And that MAC address aging time is 300 seconds. Now, how do I know it's in seconds? Well, if I were to go into global config and say MAC address table and do a question mark, you can see I can set a static entry here, right? So this is how you would manually put a static entry in. So let's just say I do 111, 111, 1111, and that should be it. And then we'll say VLAN 1, and then the interface. And I'll say Ethernet 1.1. So we're going to put this, I'm going to, sorry, let's see what it's looking for here. Oh, I'm sorry, interface. And then Ethernet 1.1. So I just created a static MAC entry for VLAN 1, and I'm tying it to Ethernet 1.1. So do show MAC address table. Now we've got a static entry in here. And I know I kind of went off on a tangent there ever so slightly. And let me see if I can get, where is desk scribble back? There we go. All right. So you can see we now have a static entry. So that, if you wanted to, if you needed to, for whatever reason, create a static MAC entry, that's how you do it. And again, I've just associated it with Ethernet 0.1, right? I'm just basically saying that, yeah, if this switch, if switch 1 receives a frame with a destination MAC address of 1.1, all ones, that traffic will be forwarded out Ethernet 1.1. And you can see here, that is my static entry. So now the commands that we were running earlier, where I was saying show MAC address table static, and we didn't see anything, now we only see the static entry. Again, if I don't want to see the static entry, I can say dynamic, and there's only my dynamic entries. So let's get back into global config. We already did this show MAC address table aging time, and we saw that it's 300 seconds. And then the question was, well, how do you know, Travis? How do you know that that's seconds? How is that not 300 minutes or 300 hours or 300 days? Well, let's go in and let's change the setting. Let's change the aging time here from the default of 300, and we're going to figure out how do I know that it's seconds. We're going to change it from 300 to, let's say, 900. So I would say MAC address table aging time. If I do the question mark here, you can see if I put a 0 in, I simply disable the aging time, but I've got a pretty wide range of values that I can use. I can make it from 10 seconds, and so here is the answer to that question. This value is entered in seconds. So I can go as short as 10 seconds and then as many as 1, 2, 3, a million it looks like, all the way up to a million seconds, right? Now, 10 seconds may be pretty quick for an entry to timeout. So Cisco has defined 5 minutes. So 300 seconds, there's 60 seconds in a minute. 5 times 60 is 300. So we've got 5 minutes here, right? So these entries, these dynamic entries, if there is no traffic being generated, and that's a critical point, right? If no traffic is being generated to those addresses, they will time out after 5 minutes. So the question is, how long do you want entries, dynamically learned MAC address table entries? Because remember, only the dynamic entries are going to be the ones that time out. Static entries will never leave the MAC address table. They will never time out because they're static. But here we've got these dynamic entries. So the question becomes, after how many seconds of not receiving traffic do we want the entries to time out? Now, again, Cisco's chosen 5 minutes. Very rarely do you need or should you need to go in and change that. However, if you do, here is how you would do it. And there's really nothing wrong in a stable environment. There's really nothing wrong with changing the aging time if you want. But again, 300 seconds, and when we get to HSRP, we'll talk about the ARP time and the ARP timeout and the MAC address table timeout and how you might and probably will be making some changes. That's off a few weeks in the course, but that is the use case where you would say, okay, wait a minute, I need to change the MAC address aging time here. But there's really nothing wrong with changing it if you want to, but again, typically in a stable environment, there's not much of a need to make that change. So we said 900, so we'll change it to 900 seconds. So there we go. So now if I say do show MAC address aging time, you can see that now dynamic entries will be held for 900 seconds. And I guess I could have made it easier on myself and I said the activity actually shows 600 seconds, which is 10 minutes, but I pushed it out to 900 seconds, right? And again, remember that this is the time for unknown unicast traffic that's coming in, right? And the switch is learning about that information. It's learning about the source MAC address in the layer 2 frame. And it's entering that information into its MAC address table. That's how long it's going to hold on to it. So if you've got, thousands and thousands of devices being plugged in all over the, plugged into the switch, constantly, you may want to hold on to that information a little longer rather than allowing it to expire out after 5 minutes. And if you did, this is how you would extend that MAC address table aging time. All right, so this wraps up Discovery Activity 1. Again, a fantastic activity to kind of break the ice and to introduce us to Layer 2 and how we're going to see that Layer 2 information and what that Layer 2 information tells us about how the switch is learning where traffic is going to be forwarded. All right, thanks for watching, and I'm looking forward to seeing you guys for the start of the semester. Have a great weekend.